All right, so today we are still looking at right triangles. So we've done Pythagorean theorem and special right triangles. Now, sometimes you'll be able to find sides and angles if you use trigonometry. Whenever you are working on a particular triangle, like if you have one that looks like this, scratch that. But you know this is a right angle, and you know this is 5, and you know this is 12, you do Pythagorean theorem to find out this is 13. If you have a special triangle, so let's say you've got a 45, 45, 90, then if this is 5, then you know this is 5, and this is 5 square root of 2. But what happens whenever you don't have enough information? Like, what if you only knew one side of this triangle? Well, then you would need to know just a little bit more, and then you would be able to find what was missing. So what we're going to do is learn about trigonometry, and we just call it trig. So it's a branch of mathematics that studies triangles and relationships between their sides and their angles. So we're going to be looking at both. So when we'll only be studying trig with right triangles, but trig isn't only limited to right triangles. We are going to do a little bit more with just your general triangle, but it'll just be very basic. So to know, why do you need to know trigonometry? So there's enormous number of uses. So for example, we can use trigonometry in astronomy. We can use it to measure distances between landmarks. Satellite, your GPS systems use trigonometry. So there's these sine and cosine functions, and they have these waves that do like this. So they're wavelengths, so that would be like your sound and your light waves. So you'll also find that trig is going to be very important whenever you get into physics. So some fields: astronomy, surveying, music theory, acoustics, optics, financial markets, electronics. There's so many different things. You can go to wikipedia.org and find out all kinds of things. So trig is useful for ultrasounds, chasing tornadoes, surveying land. So this is how we use it. So what you have to do is you have to look and see, okay, you have a right angle. Then you have this angle here. This is a B, beta. This is a Greek B. And then we have the Greek letter theta. So that's how we name our angles. We're not always going to just call them X and Y. In trig, they actually use a lot of Greek letters. So this is theta and this is beta. So if we were to, first thing you're going to have to do always first is circle the angle that you're referencing. So for example, in this particular problem, we're going to reference the angle theta. So you look across, this is your hypotenuse, I'm sorry, this is your opposite side. This side is next to your angle, so this is your adjacent side. The hypotenuse is just like in Pythagorean theorem, it's still the hypotenuse, it does not change. Now, the very same triangle, if we reference beta, now this side is adjacent, and that side is opposite. This hypotenuse still did not change. Okay, so this reads as the sine of the angle. So for example, this would be sine of theta is the opposite side over the hypotenuse. Cosine of the angle equals the adjacent side over the hypotenuse, and the tangent of the angle is the opposite side over the adjacent side. This is pronounced sine. This is pronounced cosine, and this is pronounced tangent. So those are those buttons on your calculator that you've probably wondered about. So, for example, using the right triangles above, we can set up ratios. So remember, ratios are just your fractions. So if you'll notice, trig is really just going to be using fractions and the button on your calculator. It is very, very easy, so do not get overwhelmed. All right, so we're going to set up some ratios to compare the sides, okay? We have the opposite side, which means opposite whatever angle we're talking about. You have your adjacent side, which is the angle that's next to what you're talking about. And then you have your hypotenuse, which is always opposite 90 degrees. Okay, this one is always opposite 90 degrees. So the opposite side and the adjacent side change. So they're going to change depending on which angle you're referencing, okay? So notice how the opposite side and the adjacent side are going to change. So notice when we had theta a while ago, this was opposite, but for beta, this was opposite. So it all depends on which angle you're talking about. All right, so now what we're going to do here is we use this acronym sohcahtoa, and this is to help you remember which goes with which. Okay, so for example, S stands for the sign. Okay, so S stands for the sign, where O is going to stand for opposite. And then your H is your hypotenuse. Okay, so those are the three things for so. So. Then you've got ka, which is cosine. I guess it would help if I could spell. A is adjacent. And H is your hypotenuse. And this way y'all can read my writing better. So we got ka, C-A-H. And then we've got toa, which is tangent. And then you've got the O, which stands for opposite. And then you've got the A, which stands for adjacent. Okay, so we've got tangent, opposite, adjacent. So you're going to want to write sohcahtoa. Oh, Lord. You're going to want to write sohcahtoa at the top of your paper so that you just have to glance up and look. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. And it tells you the order that they need to be set up. It's a no-fail. All right. So what about hypotenuse versus the opposite side versus the adjacent side? So labeling right triangles is very important. My mom used to always say, if you can label triangles properly with the hypotenuse, the opposite side, and the adjacent side, you can do trig. Of course, I'm kidding. My mom never told me that. She didn't even know what trigonometry is. How do you label the sides? So always go in this order. Always label the hypotenuse first because that one is the one that you know. That one never changes. It's always the same. So this would be my hypotenuse. Always. So I'm going to be referencing angle 64. So I'm going to circle my angle. This is the hypotenuse. The second one is always the one that's across from it. So that would be opposite, meaning this one has to be adjacent. Okay, so this is just practicing labeling. What about if I'm referencing angle 26? This is still my hypotenuse, but now this side is opposite and this side is adjacent. That does not look like an H. Okay, so it all depends on what angle you're talking about. So just like labeling with your special right triangles, you have to label with trig also. All right, so let's just practice labeling here. That's all we're going to do. So with reference to a specific angle, label all the sides. So we're going to talk about angle 41. So I'm going to circle my angle. The hypotenuse is always the hypotenuse. This is opposite. This one's adjacent. Number 2, if we look at angle 49, this is still my hypotenuse. It did not change. Now this one is opposite, and this one is adjacent. Okay, what about angle 30? Always the hypotenuse. Opposite, adjacent. Angle 65, I think they mean angle 55. So this is my angle of reference. This is always the hypotenuse. This is opposite. This is adjacent. So if you get the opposite and the hypotenuse, the leftovers just A. Okay, 73. Here's opposite. I'm sorry, hypotenuse. This one is opposite, leaving this one to be adjacent. 50. Hypotenuse. Across from it is opposite. Next to it is adjacent. Okay? Never changes. Okay? All right, so we're going to stop here, and I'm going to make the second part of the video so you can take a break.